In this video, we are going to solve probability problems using possibility diagrams. Let's begin by flipping two coins together. What do we get? Two heads, two tails, or a head and a tail? What's the probability of getting a head and a tail? Is it 1/4, 1/3, or half? Before making a conclusion, let's list down the possible outcomes. There are two ways to do it. Let's look at this one first. Suppose the two coins we flipped are a 10-cent coin and a 20-cent coin. We can get either a head or a tail from the 10-cent coin. Let's write the outcomes here using H and T. This line can be seen as the x-axis. The same goes for the 20-cent coin. We can write its outcomes along the y-axis. The four dots here represent the four equally likely outcomes: two heads, two tails, or a head and a tail. This is called a possibility diagram. We can also draw the possibility diagram using a table. We use the top row to represent the outcome of the 10-cent coin, the left column to represent the outcome of the 20-cent coin. Also, we use H for head and T for tail. For example, when the 10-cent coin shows a head and the 20-cent coin also shows a head, we can write it as H and H. Again, each square represents an equally likely outcome of the experiment. Let's use these diagrams to find the probability of getting a head and a tail. Do you remember this method? We know the total number of outcomes is 4. How about the number of favorable outcomes? Can you find them on the diagrams? We want to get a head and a tail. Look here, there are two. Similarly, we can find the two favorable outcomes in the table. Thus, the probability is 2/4, which is half. Do you know how to use these diagrams now? Now let's play a game. To start our turn, we have to roll two dice and get at least a 6 on one of the dice. We got it! Are we really lucky, or is it rather easy to get a 6? Let the probability tell us. Firstly, let's draw a possibility diagram. Similar to the experiment of flipping two coins, we start by listing down the outcomes of both dice. Each dot on the diagram represents an equally likely outcome. For example, this dot means getting a 5 on the first die and a 4 on the second die. So how many outcomes are there altogether? There are 6 times 6, or a total of 36 outcomes. We have drawn the possibility diagram. Now let's use it to find the probability of getting at least a 6. At least a 6 means the first die shows a 6, or the second die shows a 6, or both dice show a 6. These 11 dots represent the 11 favorable outcomes. So the probability of getting at least a 6 is 11/36. 11 out of 36 is less than half, so we are quite lucky to get a 6 on the first roll. Now, there is a change in the rule. We have to roll the pair of dice such that their sum is 7. Wow, we got it again! What's the probability of that happening? Let's use the possibility diagram to find out. Sadly, this diagram doesn't show the sum directly. How about using the table? Since we're interested in the sum of the two dice, let's add them up. Each number represents a possible outcome from adding the numbers from the two dice. Since the sum can be between 2 and 12, there are 11 different outcomes. 7 is one of the 11 outcomes. Can we say that the probability of getting 7 is 1/11? Let's test it out. Let's roll a pair of dice and add up the numbers using a computer simulation. We shall repeat this experiment 100 times. 18 out of 100 times give us 7 as the sum. Is this close to 1 out of 11? Let's compare them. Converting 1 out of 11 to a decimal, this is our guess, and this is what we get from the computer simulation. This probability almost doubles our guess. So why is our guess wrong? Let's look at the diagram again to find all the squares with a 7 in them. There are 6 of them. We have a total of 36 equally likely outcomes. The probability of getting a 7 is 6 out of 36, which is close to 0.17. This is very close to the value that we get from the computer simulation. Our initial guess 1 over 11 is wrong because we have assumed that all the 11 different outcomes are equally likely. But in fact, they're not. To conclude, we have learned 2 different ways to draw possibility diagrams. We use these diagrams to represent outcomes and thereafter to solve probability problems. In addition, the table representation on the right is more suitable when we want to show the sum or difference between the outcomes.